So today we're going to learn how to solve roots. We've done roots in here before, but we haven't done other kinds of roots. Like this is what we would call a fifth root. There's a little 5 there, and we'll talk about how to do those. Okay. All right. So let's talk about what they are. You guys know what a square root is. The square root of x answers the question, what number multiplies by itself twice to get x? So, in other words, the square root of 64 is answering the question, what number times itself makes 64? And the answer is 8. Okay? So the answer would just be 8. So you're asking what number times itself makes that, right? So the nth root of x answers the question, what number multiplies by itself n times to give me x? So for instance, suppose I gave you guys this. This is, when I say nth root, that means it could be any number. So in this case, this would be a 4th root of 16. And so square root answers what times itself makes 64. This is asking what multiplies by itself 4 times to make 16. What number would you multiply by itself 4 times to get 16? Does anybody know? 2. And that's what an nth root is. Okay? So it's just a different kind of root. All right. So to simplify square roots, you guys might remember we factored it and we took out groups of 2 because that's what square roots do, right? They look for something times itself. So if I gave you guys the square root of 8, the first thing we would do is we would break it down. And then if I had any pairs, I would circle the pair, put that number on the outside, and drop off the pair, and whatever's left on the inside stays, right? So if we do it with nth roots, let's take a look at this, for instance, square root of 24. But instead of a square root, let's say it's a 3rd root of 24. Well, we would break it apart first. And 24 is 8 times 3, right? And 8 is 3 2s. So it's 2, 2, 2, and 3. I'm not showing the factor tree. We'll do plenty of that today as a review, but for now, if you broke it down, that's what it would look like. And the difference is, instead of looking for groups of 2 things that are identical, you're looking for groups of 3 things that are identical. So in this case, for every group of 3 identical things, you could write that number on the outside and cross off the group. So that's how we'll be doing these other roots. So whatever this number is here, that's called the index, or the root is probably what I'll be calling it usually for today. That tells you how many need to be in the group in order to take it out of the root. Okay? So up here, just so you guys know, square roots have always had a little hidden number here. They just don't write it. It's always been a 2nd root. There's always been a little 2 here. They just don't write it. Kind of like whenever you have the letter x. You have the letter x. There's a 1 in the front. There's also a power of 1. They just don't write it. Well, with square roots, if they don't put anything there, it's a 2. Okay? So now we're ready to actually start doing some examples here. So now the numbers are going to be kind of big, just to let you guys know, because when you're dealing with these kinds of roots, in order to have that many pairs to take out, you have to have a lot, so the numbers get kind of big. But let's go ahead and get started here. 243. So the step 1 here is going to be to break down the number. Okay, so what times what makes 243? You guys notice that it's not an even number, right? So it doesn't end in a 0 or a 2, so it's not even. So I can't divide by 2. How about 3? Maybe 3 goes in there. Well, I see that 3 goes into 24 and 3, so it's going to go in there. So let's do 3. 3 goes into 24 8 times and 3 once. So Now, if you need a calculator to do that, that's fine. Just do 243 divided by 3, and you'll get the answer. But if you can do it mentally, that's cool. Now that we've got a smaller number, we can keep going. 81 is... So 3 goes into 24 8 times. Then I bring down the 3, and then 3 goes into 3 once. Mm-hmm. And like I said, you could just use a calculator if that sort of mental math is too strenuous. Just use a calculator. Sometimes I do too. Like if the numbers are really big, I'll just put divided by in the calculator. So long as it doesn't give you like a decimal, then it goes in there evenly. All right, so 81 is 9 times 9. And 9 is
3 times
3 times 3. All right, so now notice I haven't done anything with the x's yet. Now this is kind of a bit of a pain in the tush, so if you find a shortcut, you're welcome to use it. I'll share a shortcut with you, but if it's not obvious, maybe just kind of do it old-fashioned way. But there's 10 x's here, right? So that's kind of irritating. You have to write all those x's out. And there's a faster way. I'll share it with you in a second. But there it is. So the 243 broke up, the 81 broke up, and the 9s broke up. And here's what I'm left with. I have 1, 2, 3, 4, 5 3s and 10 x's. I'm going to squish all that in here. 5 3s and 10 x's. Okay. How many groups? How many should be in a group? This time it's 4, right? So that's what that little number there for. So I'm looking for identical groups of 4 here. So there is one group of 4. So for that group of 4, I can put a 3 on the outside and drop all 4 of those out. And we also have some x's here, right? There's a group of x's there. And I still have 4 more x's after that even. So on the outside, I have 3x squared. And on the inside, I have a 3 with 2 x's, which is 3x squared. And that's as simple as that one gets. Okay? So that's how we do nth roots. So a lot like square roots, you break it down. The only difference is that you take out 1 for bigger groups instead of just groups of 2. Okay? Now what I find to be the most struggling part for students is this step over here where you break it apart. It's just multiplication, so I say just use a calculator if you're having trouble with that. All right, let's go ahead and take a look at number 2 here. I'm going to let you guys kind of walk me through it a little bit instead of me doing it. Am I good to erase all this stuff, guys? Yeah, all right. Oh, by the way, I said I was going to share with you a shortcut for the x's, right? So let's talk about it. If you want to do this, you can. I'm just going to focus on the x's only for a second here. How many x's are there? 10. And I want to take out groups of 4, right? How many groups of 4 are there in 10?
2.
There's 2. So I could take out 2 x's. But how many x's would be left over?
2.
So you could do that if you want to. How many groups are there in there? That's your exponent out here. How many are left over? Goes inside. Okay? I could give you another one real quick here if you want to try. Let's say this is like 3. And let's say this is x to the 17th power. What am I going to have on the outside?
2.
How many groups of 3 are there? I've heard a few people say it. 5, yeah. 3 goes into 17 5 times, right? How many are left over, though? So you could do that. Okay? Instead of writing out all those x's, you just kind of do the variables separately like that. All right, so let's go ahead and do this guy, though, real quick. 625. I'm still going to do the long way when I'm up here, just in case that shortcut was a little bit confusing to people, but now that I've shared it, you're welcome to use it if you want. All right, so go ahead and take a look at that and think for a second, what do you think might divide into there? What can I break that apart into? Shakir, what do you think we could divide into 625? Yeah, because it ends in a 5, right? So let's do that. So now let's figure out what that other number is there. You might use a calculator, or maybe just do some mental division in your head. I don't know, but go ahead and try doing a little division. I'm going to call on somebody and see if you can tell me. I'll give you a second to calculate it. How many times is 5 going to 625? And let's see. So I'll ask Stephen first. Stephen, did you get one yet? Good. Nice job. True, true. All right, let's continue. Denise, what else goes into 125? Okay, so 5 goes into 125 once again because it ends in a 5, right? And she already did the division too. 5 goes into this 25 times, and then surprise, surprise. I just need more 5s. I mean, for this to work, I have to give you a lot of the same numbers, just so you guys know, because we need to be able to take those out, right? Is that everything? Okay. So let's go ahead and write this out here. Once again, I'm going to do it the long way, but if you want to do the X way, you can. The shortcut for the X's that I shared with you earlier. But there's going to be 15 X's in there. And I'm just going to stack them for the sake of space. It's not technically the right way to write this, but I'm not going to make that long of a row, so I'm just going to do that for ease. All right. So, Sharmani, in order to take out numbers, how many do there have to be in the group? There has to be 5 this time. That's what this little number out here is. So, look and see what you guys are able to take out. And I'll ask Crystal. Crystal, what are we able to take out of here?
3 groups of
5. Here's one group of 5, there's another group of 5, there's another group of 5. So for each of those groups, I could take an X out. But notice the 5s just didn't have enough. So the 5s have got to stay in there. So, Alonzo, what am I going to write on the outside here in simplest form? And then on the inside, Armani, what will I have?
I don't know.
How would I find out what I...
You multiply all of the 5s.
You're right. Now, I don't have to do any work, and here's why. Because that's what this was. That 625 was those 4 5s put together. So we don't have to calculate, it's already there. But if you did multiply them all together, you get that. All right, so usually you'll be able to take out some numbers too. There it is. So break it down. Once again, feel free to use a calculator. That's the part where I see people make mistakes a lot. We're looking for what multiplies, right? And then after that, you're going to start taking out your groups. All right, well, here's a couple for you guys to tool around with there. I'll give you all right, so we'll move on to our next bit here, and that's going to be having to do with what do you do about the negatives. So what's the square root of 4, you guys? It's 2. What's the square root of -4? Right? So you guys remember that when there's a negative under a square root, you cross it off, you put a negative in the front. And the reason we do that is because there is no number that you can multiply by itself to get a negative. That's not possible. Anytime you have a number times itself, it's always positive. You could have 2 positives, but when you multiply them, you get a positive, or you have 2 negatives. That makes a positive. You can never have 2 of the same number make a negative, and so we get what's called an imaginary number there. Let's take a look at 8. What's the cube root of 8? 2. 2 times 2 times 2 is 8. Now, some of you guys might not know that off the top of your head. That's fine. But if you were to break it apart, you would have 3 2's. You would circle that group, put a 2 on the outside, and drop the root, and just be 2. Right? You'd be tempted to say 2i, but this one actually has an answer. Let me show you. Don't you guys agree that -2 times -2 times -2 makes -8? So with cube roots, it's not imaginary. You can actually get an answer that works for that. Over here, there is nothing you can multiply by itself to get -2. That's not possible. I'm sorry, -4. Over here, though, you can get a -8 if you're doing it 3 times. And that's true for any time you have an odd power. So if you have an odd power, just do the root like you usually would. Like you guys knew the cube root of 8 was 2, right? But since it's negative, my answer is just going to be negative. So we have a little rule here then I want you guys to be aware of. If you have a square root with a negative, cross off the negative and put an I on the outside. If you have a cube root or any odd root, like a 5th root or a 7th root, cross off the negative and just put it on the outside. That's it. So for square roots, I goes on the outside. For cube roots, a negative goes on the outside. This is a real number, and this is imaginary. Okay? So that's on our next slide there. So I'll bring it up. I'll let you guys, I see some pencils moving, so I'll wait a second. So nth roots with negative radicands. This is a new word for you, possibly, radicand. If you don't know what that is, a radicand is the number that's under the square root. So in this case, x would be the radicand. So if you ever hear me say radicand, that's what I'm talking about. So when you have an nth root with a negative radicand, so what we said is that if this number out here is odd, then what we're going to do is we're going to cross the negative off, and we're just going to put a negative on the outside. It's still a real number. It's just a negative real number. But if it's a square root, then we're going to cross off the negative and put an I in the front, because that's an imaginary number. Up here, it is possible to find a number that multiplies by itself 5 times to give you a -243. So you get a real answer. Down here, it's not possible to find a number times itself twice that will give you a -18, so that's imaginary. Now, the last one, let's say it's some other even number, but it's not 2. We haven't learned that, and I'm not going to go over that with you guys. Okay, so don't worry about it. So if it's odd, the negative goes on the outside. If it's a square root, I goes on the outside. And I won't give you problems where this is an even number and this is negative, because that's not in the scope of what we're learning this year. So, all right. So let's take a look at example 2, number 1. Niana, what's the root on this one? Like, what kind of root is this? Is it a square root, a 4th root, a 3rd root, a 5th root? What kind of root? It's a 5th root because of this number right here, right? And Now I'm going to ask Michelle a simple question. Is it even or odd? It's odd. So if it's odd, Alondra, what do I do with my negative if my root is odd? You got the hard question.
Put it on the outside.
That's it. Yeah, you just cross it off and put it on the outside. That's it. Okay? The rest of the problem doesn't change. So I'm still going to break it down. Now I'm not going to show my work this time because we've already practiced that and I don't want to have you guys get lost in the weeds. But just know if we broke it down, 256, gosh, I might need to break it down. I don't know. I might have to do it. I can't do it mentally. Can you do on your calculator 2 to the
There's 8 twos.
8? Okay. So try 2 to the 8th, but Adriana's telling me it's 8. So 1, 2, 3, 4, 5, 6, 7, 8. Make sure that's 256. And then we're also going to have 10 Ks. Once again, I'm not showing my factor tree just so we don't get lost in details. The only thing I really wanted you guys to get out of this is what do you do with that negative? And we did it already. In this case, since it's an odd root, you take it out. Right? We good? All right. So how many 2's do we need in a group? I've got that here. So I can take a 2 out. And I've also got 5 K's here and 5 K's here. So I can take out 2 K's. So we'll cross off those groups. And it looks like I'm left with 3 2's on the inside. What did I say?
You said 2.
Oh, 3 2's, yeah. 3 2's on the inside. All right, so we have k times 2, which is 2k squared. And there's a negative here, so that makes it a negative 2k squared. And on the inside, 2 times 2 times 2 is 8. So the only thing that was new was this first step. Did you notice that since this is an odd number, we just take the negative out? If you got that, then the rest of it's what we did already today. Break it down and take out your groups. All right, let's take a look at the next one here. Brittany, what kind of a root is this one on number 2? Good. All right. So this is it is an even number, but more specifically, what number's there? 2. So when they don't have a number here, it's 2, and that's a square root. Now you've already given some of the answer away, but maybe they weren't paying attention. So I'm going to ask someone else the next question. But Adriana, when this is a 2, what do we do with that negative there? We put an I on the outside instead of a negative. All right. So we have I square root 18x to the 5th. And once again, I'm not going to show my tree on this one. I'm just going to do the breaking it down for you. And David, how many need to be in a group for me to take it out? It's 2. Once again, since there's no number there, we can say it's 2. So I can take out the 3. I can take out an x. And I can take out another x. So on the outside here, I've got 3x squared I. And on the inside, I've got 2x. All right, and then there's a student practice there for you guys. Once again, the only thing that's really different for the student practice is that very first step. So you're just deciding, do I put a negative or an I on the outside? So I'll let you guys work on that and see how you do. I think that might do it for the day. All right, guys, so the answer number 1 is here. and I put the important part there in red because the rest of it's old. Did you know that on number 1, the negative becomes an I? And on number 2, did you know that the negative just comes to the outside of the root? There's no I on that one. So those are our answers, and then on the sides of the room, you guys can see how they're worked out.